You may proceed, please.
Okay, very good evening to everyone. So last few sessions we were discussing about statistical analysis. Today we would start with data mining concepts. Okay, so to begin with, so let's do a recap of CRISP-DM, right? How many steps does CRISP-DM have? Yeah. How many steps? So it's a 6-stage process, right? So whenever you talk about CRISP-DM, it starts with understanding the business problem. Then we start doing the data preparation, or we can say the data collection in the second stage. Then we move on to, after we say the data is collected, we have to do data cleansing, then model building, do the evaluation, and then deployment. Right? These are the 6 stages. We know that CRISP-DM, for any project management methodology, we are going to follow. So what things we do in stage 3, friends? So in stage 3, what are the things we complete actually? The primary task, what we do, what are preferred, what things can be completed in stage 3 of same CRISP-DM. Yeah. What are the primary tasks? Yeah. So what are the primary tasks in stage 3 of CRISP-DM? So we know that there are 6 stages, right? In the 6 stages, we have the 3rd stage. The first stage is we have understood the business problem. We have recorded the objective. We have also recorded the constraints put by the client. Then he gave us the data. The data collection is done, maybe through primary source, right? Or through the secondary source. We have the data, right? So when we collected the data, what would be the next step? What would we do after collecting the data? 3rd stage. Yeah. So you have to do a kind of pre-processing, right? You have to do data cleansing, right? You start doing your exploratory data analysis. You have to do feature engineering, right? So when the data is collected, most of the time would go for data collection and then data cleansing. And so when we say data cleansing, pre-processing, what we are doing, we are checking whether the data has outliers. Then we check whether any missing values are there in the data. Then we check for any dummy variable creation is required. Right? Are there any duplicates in your data? Right? So what else we can check? You are checking your first, second, third, fourth business moment decisions. Right? What else we do? What else, friends? So once you do that dummy variable creation, you use many methods, right? So then you do your EDA, then you also do feature engineering, right? These are the major tasks what we perform. So the first three steps of crisp DM would take 80% of your time, right? So how will we know that which the data is best, right? There is no criteria that the data is best or not. We have to do deep dive into the data, check what are the other insights, what we are able to get from the data collected, how useful are they for our model building, are they useful or not, what we have collected is correct or not. So whenever the client gives the data, we are not directly using that data. You should look something outwardly also, right? When you look outwardly, then what you will know, you should take it from many sources. It could be open source, it could be social media platform, anything. Right? Based on that, you start doing your EDA part, you start doing your pre-processing steps. All these things would come into picture. Okay, now when we are talking about the stages, right? Then our fourth stage is the model building. The fourth stage is a model building. So when you talk about data mining, right? What is the scope of data mining, friends? What is the scope of data mining? Yeah. What is the scope of data mining? To bring out insights. Okay, correct. What else? So it helps you to predict mining the data. Exactly, Hare Krishna. You will do data mining, yes. But what is that? Why it is important? What insights you get? Getting insights ultimately, yes, I agree. So, it would predict trends, right? It would even help us to know the behavior, right? So data mining helps to, the process of identifying a kind of information, what it is to do, like what predictions it has to do, right? So you are trying to get some information, whether it is a small data set or it is a large data set. Predictive information is what you have to identify. So whatever pattern we didn't find previously, so we need to discover the previous unknown patterns in your data. That is the scope of data mining. Okay, so broadly classified into, what are the two approaches for data mining? Broadly classified into two. So what approach is the first and the second? Like, is there any criteria for that? How many approaches are possible for data mining? Yeah. In data mining, right, you have approaches. So broadly classified into two approaches. What are the approaches? First is your supervised learning, right? And second is your unsupervised learning, right? First is your supervised and second is your unsupervised learning. Yes, you have reinforcement learning, many other are there, but broadly we classify into supervised and unsupervised. Now, why do you call it as supervised, friends? Why supervised is called as supervised learning? Yeah. Tell me. Why it is? Why you call it as supervised? What is happening? Why it is like supervision? Maybe because of that you're calling it as supervised learning. Maybe, right? So data mining concepts, they train the machine, right? You are giving training. So when you give training, okay, known output. So when you train the machine, we are definitely trying to capture some kind of insights, right? You are also trying to capture patterns in the data. So whenever you train the machine with some kind of historical data, right? If you have set of input variables, right? The pattern is identified. So when you identify that pattern, you are not identifying pattern something like that, right? Under the supervision of Y, right? Because you need what to know. You know what someone has posted that yes, you have the known output. Y is known to you because we always consider as X being input, Y being output. So the patterns or whatever you are trying to find out, right? It is under the supervision of Y. Hence, it is called as supervised learning. Right? Y is nothing but your output. Okay. Now, whenever you talk about your, supervised, we know that Y is known to us whenever you have an option of finding out, what to predict, right? You know what you have to do. You have to predict something. But when you don't have anything like specific Y in your data, right, you are trying to draw some pattern. You're trying to draw some behavior out of your data collected. So then that is nothing but your unsupervised learning. Correct. Now, my question would be, how do you evaluate an unsupervised learning technique output? You know that in supervised learning, you're doing some predictions. Is it correct or not? You have some methods to find out whether it is correct or not. But when you don't know what you have done, what pattern you have got, how do you evaluate that? Tell me. How do you evaluate, right, an unsupervised technique output? Let me put it as learning also. Yeah. How do you evaluate an unsupervised learning technique output? So whenever you say unsupervised, yes, definitely you don't know what is why, right? So what is that? You can take one example and also you can give an explanation for that. So what are the examples of unsupervised learning? Let's talk about that first. What techniques come under unsupervised learning? Exactly, clustering, your principal component analysis, right? You have association rules, you have recommendation engine, right? All these are your unsupervised learning techniques. So how do you evaluate what you have got? It's correct or not? There's some procedure, right, for finding out the output? What is that? Suppose, see, you take clustering, right? What happens? How do you evaluate? You have formed the clusters. The clusters formed is correct or not? Because you're not, how do you know? You are formed one cluster, right? Then how it is correct? So first thing is that one way is that you determine how close each data point is there within each cluster, right? And you know that particular closeness that you are comparing with every other data point in its cluster. So what is that called as? You're trying to find out the closeness within each cluster. And also, you know, you even try to find out how closeness or how close the data points are equally close to other clusters also. Within the cluster you are trying to find out, other cluster also you are trying to find out. That is intercluster and intra-cluster distances. Right? You compare those distances, right? If you have built n number of models, right? You keep on building n number of models. So which is giving you the small intra-cluster distance and relatively large inter-cluster distances, you would take a call on it. Is it correct or not? So grouping is something, you know, we do have customers with discrete characteristics. We have data points of discrete characteristics. So it's that, you know, whenever you take any input, right, because there is no dependent variable here, each technique would give you different method of evaluating the performance. And each method has a different way. But whatever you get, you are accepting it. There is no correct, there is no something like wrong. Whatever you get, yes. But you would check differently with respect to the approach, whatever you are following. Right? So if you unsupervised techniques are your recommendation engine, association rules, your PCA, clustering, all these come under unsupervised techniques. Okay. So can someone explain me the different stages of data mining? Yeah, I'll write it as explain different stages of different stages of data mining. So you have collected the data from multiple sources, right? You have prepared it, you have done cleansing, you have done transformations, right? And it is ready for analyzing the insights, right? So one is that when you start mining the data, you are doing some kind of exploration, right? Then you try to build the models. So you are validating your data by applying different models to it. You are comparing their results, right? Which is the best performer, which model is the best, right? Then you do the deployment part. Then you do the deployment because that is correct enough. Okay. Now, when we are talking about data mining, right? And we also understood that to evaluate this particular techniques, you have different ways of evaluating supervised and unsupervised. But what is this generalization? What is this data aggregation and generalization? Is it related to clustering? Let me write it as aggregation and generalization. Yeah. Data aggregation and generalization. Both mean the same. Is there any difference? See, data is combined, right? You are doing a kind of aggregating together, right? For analysis, normal. Data aggregation, the name itself, you can understand it is nothing but you are aggregating the results, or you are aggregating the data, you are combining it for further analysis. But what is this generalization? The name itself you will understand, right? You can explain it. So it is nothing but the, you know what you do? You have to replace a kind of the data what you have, right? I can say low level data, right? With what? With high level concepts, right? So that what you do? You can generalize it and produce some meaningful insights, right? So the data can be generalized. You can produce some interesting facts or insights from the data. Okay. So whenever you're talking about, anyway, we have started with clustering, right? So if your data has outliers, assume, okay, assume the data has outliers. So what will be the appropriate kind of clustering method? What technique would be appropriate for clustering? Okay, let me put it. So data has outliers, right? So what technique will be appropriate for clustering? So what techniques we can go, friends? No, no, no. You have clustering techniques, right, Hare Krishna? Not 3R technique. That is only for outliers. You have many clustering techniques. I want you to apply a clustering technique, and I myself saying that my data has got outliers. Clustering technique. How many clustering techniques are there, or how many types of clustering are there? In that way, I'm asking you which technique you would apply if you have outliers in the data. Okay, so what you have here, whenever we always say that you have many clustering techniques, right? You have k-means, you have k-median, right? You have k-medoids, you have db scan, optics. Many are there, right? Which approach you would choose if your data has outliers? So I have given the options. Now tell me. So outliers means which business moment would get influenced. K means, right? So other than this, we can go for any of the approach for performing the clustering. Okay. So because K means mean is getting influenced by outliers. Okay. Then so if I say good clustering, what qualities does it hold? When you say, okay, the clustering is the best, right? So what qualities? What is the quality of a good clustering? Yeah. What's the quality of good clustering, friends? It would have low inter-class similarity and it should have high intra-class similarity. Then it is nothing but the clustering is the best. Right? So you are trying to, it is nothing but the ability that you are trying to discover some hidden patterns in the data, right? And you have, when you check the distances or the similarities, right? Inter-class similarity should be low and high intra-class similarity is what is a quality of good clustering. Okay, can someone help me out in writing, what are the major approaches for clustering? Do we have different approaches? What are the major clustering approaches? Okay, let me put it here. Yeah. What are the major clustering approaches? Yeah, major clustering approaches. First is partitioning approach, right? So partitioning approach is nothing but your k-means, k-medoids, Clara, Clarence. All these are your clustering approaches for partitioning. Then you have hierarchical, right? So when you talk about hierarchical, you are doing or you are creating an hierarchical decomposition of the data, right? You are doing a hierarchical decomposition of the data. Then you have density based, right? That is what DB scan, right? Based on the connectivity. It holds good for noise and it is very good on parametric approaches, right? So when you talk about density based clustering, it works with something called as radius of our neighborhoods, EPS. And if you remember, if you can recollect, right? It is something that it works with EPS, right? And also it has one more parameter called minimum points. So EPS is nothing but the radius of the neighborhoods around the data point. This is a data point, this is a radius. So what is this minimum points? It is a minimum number of data points. How many data points you want in a neighborhood so that you define it as a cluster, right? You define it as a cluster. So one more is you have grid based also. It depends upon, it is based on the multi-level granularity. Right? It's a granularity structure algorithm which is built. So there are the four major approaches for clustering: partitioning approach, hierarchical approach, density based, grid based. Okay, So these are the major clustering approaches. So any of the approach, depending upon our requirement, the number of data points we have, we can go for that particular approach. Now, so whenever you're talking about, cluster analysis, right? We have approaches, we have cluster analysis. Okay. Can you just mention the data types in cluster analysis? Right? Explain the data types in cluster analysis. Yeah. Explain the data types in cluster analysis. What data types there's a possibility that we will come across? Yeah, friends. The data types in cluster analysis. Okay, so let me write. First approach, right? You have here is intervalued variables. Okay, intervalued variables. So when we say that intervalued variables, it is a procedure what you follow, right? You check the summary of the data, you check whether they are scale free or not, you go for standardization, you go for normalization, either one of them. Then what you do, you would calculate the distances between two observations, then you try to get some conclusion, right? Then there's an option that you may have binary variables, right? You have binary variables, then you have nominal variables, and then you have variables of mixed data. Variables of mixed data. So these are the four things which are possible for cluster analysis. Right? So you have binary variables, you have nominal variables, you will have variables of mixed data also. Right? So whenever you have binary, what you do? What method you will follow? You have something like, if you can recollect, simple matching coefficient, binary Euclidean distance, Jacquard's coefficient, right? Where simple matching coefficient is nothing but it will measure the similarity between the records. Right? By binary Euclidean distance, dissimilarity between the records. Just like the error, what you get in a confusion matrix. Then you have Jacquard's coefficient, at least one similarity is matching or what. Right? Intervalued variables has that approach. Binary variables means you have this approach. Right? So now you can explain me what is nominal and what is the variables of mixed data. What approach you go? What is the procedure for nominal variables if you have, and the variables of mixed data? Right? Okay. We will discuss after knowing what we'll discuss about clustering, and then we'll go for the distance calculations also. Then my question would be, the next would be, yeah, we have understood the major clustering approaches, right? So I would like to know, what are the types of hierarchical clustering? Do you have types here? What are the types associated with hierarchical clustering? Do you have? We have only one method. Yeah, friend, tell me. What are the types of hierarchical clustering? Okay, yes, correct. Divisive, and you have agglomerative, right? Both has its own way of dealing the data, or dealing with the cluster formation, right? Agglomerative clustering is something where it finds natural grouping. It starts with n clusters. If you have n data points, you will have n clusters formation in agglomerative clustering. But when you talk about divisive, it is a top-down approach. Every node, it forms a cluster on its own. But it starts with n and stops with a singleton cluster. Yeah, exactly, Madhu. Agglomerative and divisive. Right? So it starts with n clusters, the opposite way. Both run in a different way. Agglomerative would start from n, forms one cluster. Right? So top-down approach would be your divisive. Right? Top-down approach would be your divisive. Yeah, exactly, Madhu. Yeah. Okay, then you have explained me hierarchical clustering. Then what would be the difference between hierarchical and non-hierarchical? Yeah, explain the differences. Hierarchical, yes, you have the top-down approach, the bottom-down approach. The other names would be agglomerative and divisive. Okay. Yeah. Hierarchical and what is a mistake I have made? Okay. Yeah. Non-hierarchical clustering. Hierarchical and non-hierarchical clustering, friends. Okay, first can we list out about hierarchical, then you can move on with non-hierarchical. Okay, first select the number of classes in non-hierarchical. Okay, I agree. Okay, let me put it like this. Otherwise, this is hierarchical and this is non-hierarchical. Yeah. Okay, let me write it down. Right. First, this hierarchical means it finds natural grouping. Correct? It finds natural grouping. Okay. No need to specify here how many clusters are required. No need to specify the number of clusters. Right? Here what I feel is that you have to go for dendrograms. Right? Dendrogram plot is what will help you to find out the number of clusters would be good enough. Right? When you talk about non-hierarchical, it is something that, this approach is more useful when you have large data sets. Right? When you have large data sets. Okay. So this is useful when you know how many how many clusters are required. Right? When certain K is needed, you will go for non-hierarchical clustering. Okay. So, but every time this might not be good enough, this might not be good enough, right? So, what is not important, like, which is more, to decide the number of clusters? Exactly, Madhu. So, when you talk about the clustering, right, hierarchical clustering is not preferred when you have outliers, right? Hierarchical, you don't choose this. It has its own do's and don'ts, right? Outliers will not use hierarchical clustering. It's sensitive. So what you get here, whenever you are writing, you are choosing the distance calculation, Euclidean distance calculation. What happens? You have to, it requires a lot of computational storage, right? Because you have n by n matrix, right? The computation storage is what is little like a bad about this hierarchical. And something that hierarchical clustering, once the clustering is done, though you have few records incorrectly placed, right? You have put it in, that has been done, the clustering is over, right? There is no other option for us to reallocate them. Once it is done, finish, job done. There is no other way, so that you can cross check it, and you can shift from one cluster to the other cluster. That would be add on to your non-hierarchical. Yeah, we know that now for non-hierarchical, definitely it would take long time for termination. Right? It will take long time. For whenever you talk about this, the initial partition would be different, right? Due to this initial partition, you will get different solutions. So what is the final solution? That is not guaranteed, and that would be only known from your, that how do you choose? It is not guaranteed, and that is, we can't guarantee it will be globally optimal. You have to cross check by running your different values of case. Different case, you would run the algorithm again and again, again and again. Right? So it is good in its own way. It is good in its own way. Right? Initial partition is what? Because you want to upfront know that these are my resources availability, so I want these many clusters. That time you go for k-means. Right? You don't have any other idea, you don't have anything, so you go for hierarchical. Right? Okay, but when you're talking about k value, right? Is there any option of, do you have any thumb rule for that? How do you upfront predict that you want, what is the best value of k for clustering? Suppose you have 7 million records, or 7,000 or 70,000 records. How do you decide? How do you find the best value of K? Okay, let me put it as K. Okay, let me put it for cluster formation. Exactly, Kiran, right? It's something that, root n by 2. We check. That is one way. Root n by 2 is a thumb rule. You check that. Okay. And one more thing is that any other ways, Kiran? Any other way we can check the best value of K? We have a thumb rule that root n by 2. Exactly. Correct. What are the other ways you can check for the best value of K? Exactly. Right. Elbow curve. Right. Where you have a steep bend, that many value of that particular K value you would choose. That is nothing but also called as your scree plot. Exactly, Subhajit. That is nothing but your scree plot. And also one more thing I would like to know. Yeah, yes, Madhu. But one more thing is also there. Think which K. Just now I told you inter cluster distances. What is that? You can even check for total within sum of squares. Right? You would capture total within sum of squares. For different K values, choose which is least. Correct? TWSS is what you have to check. Right? Then that particular K is what you think that it is the best K value. Yeah, exactly. TWS is a total within sum of the squares. Okay. We are talking about, yes, K value. We are talking about clustering, right? How is it possible if you have, just now I told you, right? You have different data types in cluster analysis. So if you have nominal variables, how do you measure the similarity, friends? Yeah, Madhu, BWSS and TWSS. Exactly, Kiran. Between sum of squares should be maximum, right? Between sum of the squares should be the distance. Within sum of the squares, closeness. If we have like this, sanitizer would come into juice section because it is a liquid. So sanitizer, though it is a liquid, it would be in its own place. Juices, it would be in its own cluster. So between sum of the squares should be maximum. Within the similarities between, in a cluster, it should be less. That is the best value of K. Exactly. Yeah. Okay. If you have nominal variable, how do you find out the similarity? How do you measure the similarity? Think. It is binary data. If it is categorical data, okay, if let me put it like this. If it is categorical data, if you have greater than 2, if it is binary simple matching coefficient, Jaccard's coefficient, binary Euclidean distance, yes. But if you have nominal data, yeah. Okay, first convert into binary. Binary means only 2. See, if you have sedans, if you have hatchback, if you have MUVs, if you have sports utility vehicles, 4 are there. How do you find out the similarity? Yeah, okay, discrete data. In discrete, you have count and categorical. I'm talking about categorical, where you have nominal data and ordinal data. I'm talking about nominal data. It means categorical. How do you measure the similarity, friends? I can say between the records. Yeah. Okay. Go ahead. It is for mixed data type. It's simple, right, friends? If the distance is if you have greater than two nominal variables, right? If you have greater than two nominal variables, distance between both of them would be equal to 0 if both items have same category. If they are different, you consider the distance is equal to 1. Correct? You just check like this. How do you check? You have sedan, you have hatchback, type of cars I'm talking about, MUVs and sports utility vehicles. Again, I have sedan. You're checking, right? This and this. They are not same category. So I consider the distance would be equal to 1. Again, I check with this. For this, distance is equal to 1. Again, I check for this. The distance is equal to 1. For sedan and sedan, same category. Right? Then I write distance is equal to 0. Correct? No. I'm not talking about one hot encoding or anything like that. It is being calculated between if you have categorical variable. If you have categorical variable. So now what you have told. If you have mixed data type, you have category and numerical data. It's a combination. How would you do? Now your answer comes into picture. If we have mixed data, yeah, now it's correct, right? If you have mixed data type, how do you measure the similarity? Two ways are possible here, right? One is your exactly what you have told. There's nothing but your dissimilarity coefficient. Towards dissimilarity coefficient. So what it talks about? It talks about the K, right? It talks about I, J, K with D, I, J, K by I, J, K. So Dijk, it means that it is a distance for kth variable. Wij will be equal to 1 or 0, right? So depending whether you are comparing, the comparison is therefore valid for kth variable. The comparison is valid for the kth variable or not. So k is equal to 1. Means on column 1, k equal to 2 on column 2, right? K is that k for us. What's the other approach? What would be the other approach? So any distance measure you can follow, right? When you have mixed data, any distance measure would do, right? First thing is that the approach would be you would normalize the data, right? Now someone just posted one hot encoding, right? Convert non-numeric data into numeric data. Normalization is the first step. Then you will convert non-numeric to numeric. Then you calculate Euclidean distance for the entire data. Because when you do normalization, right? You do normalization first. Everything would be in the range of 0 to 1, right? Then you convert using one hot encoding technique, the non-numeric to numeric. Then you will go for any of the distance calculation, right? You will go for distance calculation, Euclidean distance, right? Manhattan distance, Vanderbilt distance, whatever. Okay, right? So if you know what is normalization, you all know, right? This is how you calculate you do normalization. So normalization is what? It is nothing but data cleansing technique. So this comes under third stage of your CRISP DM. Okay. Now my question would be, if you do normalization or if you go for standardization, right? Clusters would differ or not? The same cluster formation do you expect when you go for normalizing the data or standardizing the data? Can we do that? You have started with normalizing the data. No, Subhajit, they do differ. And when you go for normalization, the way of cluster formation is different because the range of data being scale free, it would be between 0 and 1. But when you go for standardization, maybe you have -4 to 4, the range, right? So there is a chance that they would be differing. So you can go, which is the best cluster formation, right? Wherever you are going to give a very good labeling is done easily, this approach or this approach. Okay. When you talk about you have find it, you have went for the approach, very good, right? So when we talk about the types of clustering or the types of distance calculation or the types of data we have when approaches or everything, we are not getting same output for k-means, correct? The output of k-means is same for every execution. Yeah, usually few books give even -4 to 4 also, Madhu. Yeah, -3.4 to 3.4 is correct. But we give a very wider range of -4 to 4. Output for k-means is same for every execution, friends? No, right? Every time the execution, new cluster formations are happening. You will get different DWS's value. Right? You would even get between this BSS value also different. Correct? So now let me ask you, is k-means having a different name because of this execution criteria? If you take, do you have a different name for k-means? Yeah. Output for k-means is not same for every execution. Correct. It's not same. I agree. But okay, because of that reason, k-means is also called as, it has a name. Only because of this reason. K plus plus. No. Okay, let me put it in this way. Non-hierarchical clustering. In non-hierarchical clustering, this is one approach, k-means. Right? Okay, now you'll answer. Is k-means a deterministic or non-deterministic? Deterministic or non-deterministic algorithm? Now you will tell me. Deterministic algorithm or non-deterministic algorithm? Exactly. Only because of the reason that every time you get a new cluster formation, right, the output is not stable enough. You call this as non-deterministic algorithm. Okay. Okay. My next question would be, does clustering help in EDA? Tell me. This particular clustering helps in EDA method. EDA is your third kind of exploratory data analysis, right? Okay, then explain. Yes, yes, I agree. Explain. How can you justify? How? Chances are there. Yes, yes, the answer is correct. Yes, there are chances. How? What? See, this is a pre-processing step for other algorithms, friends. Clustering is a pre-processing step for other algorithm. So this is a standalone tool to get data distributions. Right? This is a pre-processing step. And when we say pre-processing, yes, definitely it is a EDA method. Okay. So the main objective of clustering is what? You are grouping the records, you are identifying the homogeneous groups. That is the main objective here for clustering. So whenever you try to do clustering, how do you interpret the clustering output? You are doing clustering. How do you interpret that particular clustering output? So it's nothing but after you do compute and you find out the optimal clusters, what is the next thing you do? How do you interpret that? By logical name, by naming the clusters. Okay. Any other way? Think what did we do when we have done clustering? You have computed the optimal clusters, you got it. Then you have done something like aggregation. Remember, aggregate the measures like you do for mean on all the variables, and also you would try to capture the resultant values for all the variables. And then you will take a call and give names to that particular clusters formed, optimum number of clusters, whatever they are formed. So what you do, whatever the clusters are formed, you have to do the aggregation. Correct? Now, the next question would be, what is the minimum number of variables required to perform clustering? Yeah. What is the minimum number of maximum, minimum, standard deviation, variance are calculated? Okay, to interpret clustering output, exactly. You will do aggregation, remember? If you have 5 variables, after the cluster formation, you group them and you do aggregation for that. Right? Now my next question, what is the minimum number of features are required? Minimum you want 6 features? Think. To perform clustering? Exactly, Kiran. One variable is more than enough, right? One variable is more than enough to do clustering. Male and female. Gender, you put all male and all female. Only one column you have. One variable is there. Gender. So you can put all the male, all the female into one. Right? Okay. How do you determine this nearness of a cluster? There's something called as nearness, right? How do you determine that? There is one technique to determine the nearness of the clusters. Tell me. So we are covering only on clusters for the day. Yeah. Nearness. Remember, the distance calculation between the two clusters is also possible. Yeah, by that is distance between the two clusters is what you measure. You have many methods, right? You have linkages. You call it as linkages through the concept of linkage. You can go for single linkage, complete linkage, average linkage, and centroid linkage. Right? So when you go for single, it is the minimum distance between the members of two clusters. Complete is maximum distance between the members of two clusters. So using all this, how do you determine the nearness of the cluster? Which linkage? One is correct. Intercluster distance is what you are trying to find out. Intercluster distance is what you can find out. And also through the distances of centroids, right? You measure the cluster distances by the distances of centroids, which will help you determine the nearness of the cluster. Okay. So these are the major questions, friends, that you can explore more with the linkages. right? So this is for the day. So we'll continue for the next set of questions in the next week. Okay, thank you so much. Okay, I'll stop here and we'll continue next week, same time. Thank you.